Just going to demonstrate how a transformer works. First of all, we just need to be clear about a couple of things. As we know, if we pass a conductor through a magnetic field, we generate a current in that conductor. It stands to reason that if I keep the conductor still and pass a magnetic field over the conductor, the same thing's going to happen. That's exactly the principle of a transformer. What I've actually got here is a coil of wire which is connected to an AC circuit. So 50 times a second, the current is changing direction in this coil, generating a magnetic field which is forever changing. The magnetic field flows through this transformer core. Now, it flows through a second coil. This second coil has more coils of wire on it than the one that's being supplied from my power pack. So it stands to reason that I'm going to get more energy out than I'm putting in. Now I know that there are 7 times more turns on this coil as there are on this coil. If I now turn this on and pass 10 volts through the primary coil, I should be getting somewhere near 70 volts out the other end. It's not going to be accurate because we've got some losses. It's relying on the magnetic field flowing through backwards and forwards through this coil. If I interrupt that magnetic field by pulling that out, we can see that the voltage drops considerably because obviously the magnetic field has got to jump through air to complete the circuit. So that's really the principle of a transformer. So I've turned the transformer around so that the primary coil is connected to our AC supply and our secondary coil is connected to the multimeter. If I now turn it on, we said this is a 7-to-1 ratio, but of course there's lots of losses in this transformer and they're amplified, of course, because it's a step-down transformer and it just shows up more. So we're not really getting 7-to-1 down, are we? We're getting far less, but it just proves that AC current we can transform either to a larger degree or a smaller degree as we wish. If I withdraw that, you can see that the energy now drops to pretty near nothing at all. So we've broken the magnetic field, place this back in, and the voltage will come back up again. So we've seen now that how by using AC, we can increase the voltage or reduce the voltage using a step up or a step down transformer. What I want to do now is show you that we can't transform DC so easily. It doesn't work because we're really relying on that continual movement of the current backwards and forwards through these coils. Of course with DC we won't get that, but if I turn the transformer around we'll just show you how it works. I've now turned the transformer around so that it is like a step up transformer again. If I turn this on, I'm now passing a DC current through it, and of course the DC current is only travelling one way. So it transfers the magnetism only one way through this core. And if we look, we can see that the digital reading on that is 0 because we're actually generating no voltage at all. The big difference with this is that because it's DC, it's actually creating a much larger magnetism. And no matter how hard I try, I will not be able to pull that out of there anymore. And if you can remember, when it was on AC, it came out very easily. What this little experiment has shown us is that we can actually transform AC and we can higher or lower the voltages as we want to, really, by using turns of wire on a core. Of course, what we've seen also is we can't do that with DC because the current flows only one way, and so the magnetic field only flows one way. What we have seen though is that if we want magnetism, DC is by far the better medium to use than AC.